Okay, hi Chem 30. I'm going to give you guys, this is a demo lab. This is the buffer lab that I'm going to give you. This is the outline that I want you to do for this lab. So what I'm requiring you to do, so you can pause this on the video, I'm requiring you to make a hypothesis. I want variables. You need to give me an evidence table and a conclusion. All right? So I'm not going to give you much more direction than that because because we should all know how to do a lab by now. This is your real world connection for this. So these are the criteria I want you to answer. So as I go through, I'm not requiring an experimental setup or anything like that. Hypothesis, which is prediction, variables, evidence table, and conclusion. And analysis / conclusion is your evaluation, so a combination of those. So that's what I want you to hand in. So you're going to Dropbox that. So whether you take a picture of it in your lab book or you Dropbox another document, I don't really care. I will give you a due date for this on D2L. Now this is going to be, so this is where my evidence is going to be, so you can probably make this look nicer. So I'm going to have a buffer solution, and I'm going to have a sodium chloride control solution. This lab is on page 769. Okay, so testing a buffer effect. All right, so I'm going to go through the procedure, and I'm going to have Mr. He help me out here. And I'm going to do the lab and then execute the results. So as we go through, you can just listen to what I'm saying and then you'll see what I'm doing as it's videotaped. So step 1 says obtain 50 milliliters of 0.10 mole per liter KH2PO4. So that's what this is. So I'm making my buffer solution right now. So I'm going to top this off with a dropper bottle. Okay, it's not quite 50 mils yet. Bottom of the meniscus. And we should, for the most part, be good to go. And I need 29 milliliters of 0.10 mole per liter NaOH as well. Okay, so this one was already used. That's my H2PO4. And now I need 29 mils of sodium hydroxide. I'll top it off with the dropper bottle. I'm going to measure to the bottom of the meniscus. And that should be good. Okay. So I have, thank you. I have the potassium phosphite and the sodium hydroxide. And then I'm going to pour these two into a beaker. And this is going to give me a buffer solution with a pH of 7. Okay? Now remember, buffers are solutions that resist change in pH. Okay? And if you look back, I'll take that for a sec. If you look back at your equation, this is the buffer solution equation. Okay? So H2PO4 negative plus OH negative. So you have a strong base and a weak acid, and this helps make a buffer solution. So this should help resist pH. Okay, now I'm going to have a full lecture on buffers. I introduced them the other day. But we still have a little bit of research to do on that. Okay, so supplement this lab with the lecture as well, and that should help you. So essentially, what we're looking at doing here is I'm going to pour an equal volume of the buffer solution into 2 test tubes. Roughly an equal volume. Okay. Okay. And I'm going to add 0.10 mole per liter sodium chloride as a control into a 3rd and 4th test tube. So this is my sodium chloride here. I need to add an equal volume of this into my test tubes. Okay, so I need an equal volume of this in these other test tubes. So this is a control. And what I'm going to do here is I'm going to treat these solutions with either hydrochloric acid or sodium hydroxide. And we're going to look at which one resists pH change longer. Okay, that's about equal. This could use a little bit more. Okay. All right. So that's my buffer solution. This is my sodium chloride. And let me just label that. Okay. So what I'm instructed to do now is add 2 drops of bromocresol green to one of the buffer solutions. And one of the sodium chloride control solutions. Okay. And then I'm going to add and count drops of 0.10 mole per liter hydrochloric acid until I see a color change. So I'm adding an acidic solution to this first test trial. Okay, this is 0.10 mole per liter hydrochloric acid. So with your hypothesis, what you're going to predict is, right, so if a buffer solution is treated with a strong acid and or a strong base versus a control, you're going to predict which one will take the greater amount of drops. All right? And then you're going to, with your because portion, you're going to tell me why either the buffer solution or the control solution should take a greater amount of drops in order to change color, which is a sign of right, neutralization. Okay? Or a sign of the pH changing, right? So when the color changes, the pH has changed significantly. And remember, buffers resist pH change. So from that, I mean, theoretically, right, the buffer should take more drops to change color because there should be a greater resistance to pH change because of the conjugate acid-base relationship with the buffer. Okay, so let's see if that is true. So this is the control. So let's add HCl. So that's 1, 2, 3, 4, 5, 6, 7, 8, and we're done. Okay, so that's 8 drops with hydrochloric acid. So I'm going to write that down. I'll show you my results list after. Now, this is the buffer solution, and we're going to add the hydrochloric acid to it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see if this changes. Not yet. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you can see that it's starting to change up top a little bit. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 37, 38, 39, 40. Okay, so it's still resisting pH change. It's not changing color. That's 40 drops. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. Okay, so now we're starting to see a more prominent color change. It's going a yellow-green. So let's stop there. All right, so the buffer solution in the HCl took 53 drops. So that's a pretty clear indicator that this resists pH change.
Can you turn this way? Okay, because I see this. Can you turn this way?
Oh, turn it the other way?
Yeah, let's see clear. Yeah. Yeah, that's better.
Okay, so if we're just going to flip it so you guys can see it better. This is the NaCl control, and this is the buffer solution. Okay, so you can see the color change here. All right, so this is, I gotta flip this actually. Okay, so if I look at my solutions now, this is my NaCl control and this is my buffer solution. I'm gonna do the same thing for this, but I'm gonna add phenolphthalein. That's the NaCl. You can see that. It's there's chloride ion in there, so it looks like a milky white precipitate with phenolphthalein. And then the buffer solution does the same thing with the sodium present. And I'm going to use sodium hydroxide now. So I'm going to use a base treatment. Okay, so this is the control. So 1, 2, changes pretty much instantaneously. Okay, so 2 drops. I could have said 1, but whatever. Okay, now let's look at the buffer solution. 1, 2, 3, 4, 5, 6, 7. So you're starting to see a little bit of pink in there, but it took about 3 or 4 drops, and then the pink goes away. 8, 9, 10, 11, 12, 13, 14. No, not yet. 14, 15, 16, 17. 18, 19, 20, 21, 22, 23, 24, 25. Not yet. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 36, 37, 38, 39, 40, 41, 42, 43, 44. 46, 47, 48, 49, 50, 51, 52. So you're seeing the pink starting to show up. 53, 54, 55, 56, 57, 58, 59, 60. Still not permanent color change though. 61, 62, 63, 64, 65, 66, 67. 68, 69, 70, 71, 72, 73, 74, 75, 70, 76, 77, 78, 79, 80, 81. 81 drops. Just one sec here. Just gonna top my drop bottle up. 82, 83, 84, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 90, 96, 97, 98, 99, 100, 101, 102, 103, 4, 5, 6, 7, 8, 9, 110 drops. Okay, so you can see the pink starting to show up a bit more prominently. 111, 112, 113, 114, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 124, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 45, 146, 47, 48, 49, 150. So there's a permanent change up at the top. You can kind of see that if you put it on top there. This is going to take a while so you can see that right now. It's actually, that's kind of cool. You've got the base actually separating out from the sodium chloride. So the base is on top. Sorry, from the buffer solution, I should say. So it's starting to separate itself out. So that's 150 drops. I don't know if I'm going to go to the permanent color change, but 60. That's 160 drops. I'm going to leave it there. You get the point. The buffer takes many, many more drops. So it takes much, much more base to significantly change the pH. All right. So I've added over, so this is greater than 160 drops of NaOH. So you can clearly see from the results with the buffer solution that when treated with hydrochloric acid, it takes many more drops for the pH to change significantly, and it took much less drops for the pH to change significantly with a non-buffering solution. And then here with the basic solution, it took even more. I didn't even get to the end. This is fine. We're just looking at a general trend, but it changed almost instantaneously in the control solution. But in the buffer solution, when we added sodium hydroxide, we were still going past 160 drops. So the pH has been resisted greatly here. So this is your results. So I want you to put this into an evidence table, and then you can use that to do your evaluation and analysis. So just a reminder, this is what I'm requiring you do for the lab. So the prediction is the hypothesis if then because you're talking about the base capabilities in comparison to a control and a hydrochloric acid and sodium hydroxide solution. Your because portion is why the buffer should resist pH change. Again, you'll reference the lectures as well. I want you to write these variables out, and I want you to be specific with the controlled variable. Your measurements are in the lab on page 769 as well, and I've gone through it in the virtual lab. So you should know where your controlled variables are, your manipulated variables, your responding, and you could write a control, right? The sodium chloride is a control for a comparison. So I'm not going to give you any more details about the manipulated and responding variables. You should be good with that. Evidence I've given you, so put that in a table. Analysis and evaluations are these two parts, all right? Summarize your results, right? Go back to your hypothesis, affirm whether or not your hypothesis is correct or incorrect. That's really what that's saying, okay? And then talk about carbonic acid buffering. This will be in a lecture upcoming. All right, so that's the lab. I'll put a due date on D2L, and that's your acid-base buffering lab. All right, so we're going to sign off now, guys. Have a good one.